want to introduce an interesting technology to you, COAP. I'm sure most of you haven't heard this name before, but it's actually very close to our daily lives. Let's take our time to talk about what COAP is, how it works, and why it's so useful for the smart world around us. First, COAP stands for Constrained Application Protocol. Let's break down this name to make it easier. Constrained means limited, like when you have a small backpack that can't hold too many things. Application here just means a tool for a specific job. Protocol is like a set of rules for talking or communicating. So put together, COAP is a communication rulebook for devices that have limits. Small devices with not much power, memory, or data. Just like WeChat or QQ we use every day to chat with friends, COAP is a communication tool. But here's the big difference. WeChat is for people to talk to each other, but COAP is for smart devices to talk to each other or to computers. Let's think about all the small things around us. Do you have a smartwatch that tracks your steps? Or does your home have smart lights that you can turn on with your phone? Maybe you've seen thermometers that send temperature data to an app, or sensors in gardens that check if plants need water. All these small devices are constrained. They're not as powerful as your phone or laptop. They can't store a lot of information, they don't have much battery power, and they can't use a lot of mobile data or Wi-Fi. That's where COAP comes in. It's made just for these small, limited devices. Let's talk about why COAP is perfect for these devices. First, it uses very little data. When a smart device sends a message with COAP, the message is super small, like a short text message instead of a long video. For example, imagine a sensor in a farm's soil. Its job is to check if the soil is dry and send a message to the farmer's phone saying need water. With COAP, this message is just a few simple words in code, no extra useless stuff. If the sensor used a different protocol, like the one we use to browse websites called HTTP, the message would be much bigger, like sending a whole book just to say I'm hungry. That would waste the sensor's battery and use more data than it needs to. Second, COAP is fast. Because the messages are small, they travel quickly from one device to another. Think about a smart smoke detector in your home. If there's a fire, it needs to send an alert to your phone right away. COAP makes sure that alert gets there in seconds, not minutes. That's really important for keeping us safe. Third, COAP saves battery power. Most small smart devices run on batteries like your smartwatch or a sensor in a forest that checks air quality. These batteries can't be charged every day, so they need to last 4 months or even years. COAP uses so little energy that the device's battery stays charged much longer. If a device used a protocol that needed a lot of power, its battery would die quickly and no one would want to use it. Let's compare COAP to something you might know, HTTP. HTTP is the protocol we use to visit websites, watch videos online, or send emails. It's great for big devices like computers and phones because it can handle large amounts of data, but it's like driving a big truck to deliver a single apple. It works, but it's not efficient. COAP is like riding a bicycle to deliver that apple. It's small, fast, and doesn't use much energy. Both get the job done, but COAP is better for small, simple tasks while HTTP is better for big, complex ones. Now, let's talk about where we can find COAP in real life. It's used in so many places, even if we don't notice it. One common place is smart homes. Your smart TV, smart speaker, and smart thermostat might all use COAP to talk to each other. For example, when you tell your smart speaker, turn on the living room light, your speaker uses COAP to send a small message to the light, and the light turns on right away. No lag, no extra data, just a quick, simple conversation between two devices. COAP is also used in industrial settings. Factories have many small sensors that check if machines are working properly. These sensors send data to a computer using COAP, so the factory workers can see if a machine is broken or needs to be fixed. This helps factories work better and safer. Another place COAP is used is in environmental monitoring. Scientists put sensors in oceans, forests, or mountains to check things like water pollution, air quality, or temperature. These sensors are far away from cities, so they can't be charged often and can't use much data. COAP lets them send important environmental data back to the scientists' computers without wasting battery or data. This helps us learn more about our planet and protect it. COAP is even used in healthcare. Some medical devices, like a smart band that checks a patient's heart rate, use COAP to send data to doctors. If a patient's heart rate is too high or too low, the device sends an alert to the doctor's phone right away using COAP. This helps doctors take care of patients faster, even if they're not in the same room. Let's think of another example to make this clearer. Imagine you have a smart plant pot at home. The pot has a small sensor that checks how much water is in the soil. Every day, the sensor uses code to send a message to your phone app. If the soil is wet, the message says soil is good. If it's dry, it says water me. Because COPE uses so little data and power, the sensor in the pot can work for months without needing a new battery. You don't have to worry about charging it, and you always know when your plant needs water, all thanks to COPE. Another example, smart traffic lights. In some cities, traffic lights have sensors that check how many cars are on the road. These sensors use COPE to send data to a central computer. The computer then adjusts the traffic lights, making the green light longer if there are many cars, or shorter if the road is empty. This helps reduce traffic jams and makes our commutes faster. Without COPE, these sensors would use too much power and data, and the traffic lights wouldn't work as well. Let's recap what we've learned. COPE is a communication protocol for small, limited smart devices. It's great because it uses little data, is fast, and saves battery. It's like a special language for smart devices that can't speak the same language as big devices. We can find COPE in smart homes, farms, factories, environmental sensors, healthcare devices, and even traffic lights. It helps these devices work together smoothly, making our lives smarter, safer, and more convenient. You might be wondering, why do we need COPE when we already have other protocols? Well, because not all devices are the same. Big devices like phones and computers need big, powerful protocols like HTTP, but small devices like sensors and smartwatches need something small and efficient. That's COPE. It's all about using the right tool for the job. Just like you wouldn't use a hammer to write a paper, you wouldn't use HTTP for a small sensor. COPE is the perfect tool for these small devices. As technology gets better and better, we'll have more and more smart devices in our lives. From smart toys to smart cities, these devices will need to communicate with each other, and COPE will be there to help. It's a simple but powerful technology that's making the world more connected and intelligent. In conclusion, COPE is not a complicated technology. It's just a smart, efficient way for small devices to talk to each other. It uses little data, is fast, saves battery, and is used in so many parts of our daily lives. Next time you use a smart device, remember, there might be COPE working behind the scenes, helping it send messages quickly and efficiently. I hope this introduction helped you understand what COPE is and why it's so important. Thank you for listening.